Hi, it's Ms. McCahan, and up to this point we've talked about congruent triangles, and we've said that if we know that all three angles are congruent and all three sides are congruent, then those triangles are congruent, just like these two triangles here. But now we're going to talk about SSS, which means side, 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 and we're going to look at some scenarios here. So let's say I have three different sizes of lengths, and I'm just going to try to make a triangle out of them. So I'm going to take this red line, this black line, and this blue line, and try to make a triangle out of that. Okay, so if I have sides that are the exact same length, notice that the red and blue and the black are the same exact size, then there's only really one way I can make that triangle. Even though I can maybe put the black line up here, these are the exact same size triangles. So these are congruent triangles. And that is exactly what the side, side, side congruence postulate says. If we have three sides of one triangle congruent to three sides of another triangle, then those two triangles are going to be congruent. Notice that we don't have to know anything about those angles. The fact that those sides are congruent to each other is enough to know that these triangles are congruent. So let's go through each of these scenarios and see which ones are congruent. So this first one, number one, we have two sides that are the same here with one tick mark, two sides that are the same here with two tick marks, and two sides with three tick marks. So we have a situation where we have side, side, side. So we know these two triangles are congruent to each other. Now in example 2, we have an angle that's marked congruent. We have one side marked congruent with this one, and then we have another side marked congruent with two tick marks here. Now we don't have a third side, so we don't really know if this side length is congruent to this side length, and we just have this other random angle. So we really don't have enough information to know whether these are congruent or not, even though they may look like they're congruent. And then this last one, we have this tick mark here, marked congruent to this side over here. We've got this side congruent to this side, but we don't have this third side marked congruent. But however, we do know that that would be considered our third congruent side because it's the same exact side. These triangles share the exact same side, so we know that they would be congruent to each other. So let's say we were trying to prove a situation like this, where triangle ABD is congruent to triangle CBD. And notice what we have. We know that AB is congruent to BC, that's given. We know AD is congruent to DC, that's also given. But we would need to also say that this third side, BD, is congruent to itself. Now, I know we don't really hold a lot of weight for the reflexive property, but this is a great use of the reflexive property. So we can say that BD is congruent to itself, and that's by the reflexive property of congruence. So once we have all three of those sides, then we can say, well, triangle ABD is congruent to triangle CBD, and we know that because of the side, side, side congruence postulate. And you can just mark that with SSS. So we're going to be doing more proofs with congruent triangles, but now we've got a shortcut way to prove triangles congruent with side, side, side.